The Brenner Base Tunnel. From the idea to the actual construction. A well-running transport infrastructure is essential to maintaining the European Union's competitiveness and prosperity. The 10T policy supports the completion of priority projects, representing high European added value, as well as projects of common interest and traffic management systems that will play a key role in facilitating the mobility of goods and passengers within the European Union. One of these corridors is the Scandinavian Mediterranean 10 corridor from Helsinki, Finland to La Valletta, Malta. One of the most challenging sections runs through the Alps, where a new railway tunnel, the Brenner Base Tunnel, between Austria and Italy is under construction. Why is the construction of the Brenner Base Tunnel so important for Europe? Demands on mobility and economical exchange have grown rapidly over the last few decades. Today, nearly 2 million trucks pass through the narrow valleys of Tyrol and Alto Adige over the Brenner Pass, either on the motorway or by rail. This is more than 40% of the entire Alpine north-south traffic. All those trucks put together would build a chain that's 38,000 kilometers long. That's almost as long as the equator. The old railway line over the Brenner was built between 1860 and 1867 under the Austrian Empire. It was constructed for the needs of the 19th century, with steep uphill and downhill slopes crossing the Brenner Pass, located at 1,370 meters above sea level. It is, in fact, one of the steepest mountain railways in the world. Thanks to the new virtually horizontal Brenner Base Tunnel, train traffic will no longer have to contend with the steep uphill and downhill slopes. Each day, 400 high-capacity trains will dash through the tunnels below the Alps. Passengers will speed through the tubes at 250 kilometers per hour. High-speed trains will reduce travel times by 2/3. But let's take a closer look at the tunnel system. The Brenner Base Tunnel will be 64 kilometers long, and it will be the longest underground railway connection in the world. It consists of two one-track tubes, one for each direction. They are connected at regular 333-meter intervals by cross tunnels, which will serve as escape routes in emergency situations. Underground emergency stations, which feature direct access to the surface through lateral access tunnels, are planned every 20 kilometers. Their function is to ensure the safety of passengers in case of an emergency. What is really special is the exploratory tunnel, running 12 meters below the two main tubes. But what is the function of this extra tunnel? First of all, it is needed for geological prospecting and for the underground transport of excavated rock. Once the main tunnel is completed, it will be used as a water drainage tunnel and for different maintenance purposes. The entire tunnel system will extend over a distance of more than 230 kilometers. And how much will the project cost? The estimated costs of this new railway infrastructure amount to 10 billion euros. Next to it, you see similar projects like the Gotthard Tunnel, the Channel Tunnel, the Palm, Jumeirah, or the Three Gorges Dam, and their costs to compare. The costs are divided between Austria, Italy, and the European Union, which is co-financing the project with a maximum grant level of 40%. Responsible for the entire project is BBTSE, a European company owned by the Austrian rail company ÖBB and the TFB, Tunnel Ferroviario del Brennero. But let's get back to the tunnel. Most of it is being excavated by tunnel boring machines, but in some areas, the old drill and blast method is still the better way. What remains in both methods is the spoil that has to be taken out of the mountain. The entire construction involves about 22 million cubic meters of excavated material. This volume is equal to 8.5 times the volume of the Cheops Pyramid in Giza. 2/3 of the material will have to be disposed of. 1/3 is considered reusable as a concrete aggregate for the tunnel or other purposes. The spoil will be disposed of near the lateral access tunnels in order to avoid unnecessary traffic through the surrounding villages. Conveyor belts will bring the material directly to the disposal areas. Once the disposal phases are complete, the layer of topsoil, humus, will be replaced. The meadows will be restored to agricultural use, and any former wooded areas will be replanted with typical native trees. To safeguard the water resources, all known springs, rivers, lakes, superficial bodies of water, and aquifers along the route will be monitored at approximately 1,400 various checkpoints. This procedure is unique to this project. By 2025, the project should be completed, and at the end of 2026, the longest underground railway connection is expected to start operations.